Hey guys, these are separating mixtures notes. If you haven't already, get out your notebook or wherever you do your notes, your piece of paper, something to write with, so we can get started. Just a reminder, if I go too fast, you can pause the video at any time. All right, in our last notes of classification of matter, we talked about mixtures and we said that there are heterogeneous and homogeneous mixtures. And specifically right now, I want to talk about those homogeneous mixtures. We call those solutions. And really, you need to know in a solution, you can't see the separate particles with the naked eye. We lost our camera. Why would that be? All right, so our solutions again, we can't see the particles with the naked eye. Solutions have two parts. We have the solvent and the solute. The solvent is typically a liquid and it's what does the dissolving. And our solute is whatever gets dissolved. An example of a solvent might be water. And the solute that could get dissolved in there is sugar. So the three vocab words we just discussed are solutions, solvent, and solute. We have something that we call the universal solvent, and that is water, because if it says dissolve this, universally we think of water. There are other solvents, maybe like isopropyl alcohol that we'll use in chemistry, hydrogen peroxide, other things that could do this dissolving, but the universal, once again, is water. All right, now that we've talked about these mixtures, if it is a mixture, it can be separated. It's kind of the definition of a mixture. So let's add that note here. Big misconception that even if it's homogeneous, people think, well, I can't see the different parts, so I can't separate it. But that's not true. There are different processes to do that. So we'll go down here and start discussing those and doodling them together. Let's move my camera. So one of the first means of separation that we think of is filtration. So we're going to use a filter to separate particles that it can catch. Typically you think we have a funnel. And in that funnel, you would put some filter paper. And that would catch the solids so you can separate it. Kind of think like a coffee filter. So if we had a mixture of sand and water, we could pour it through here. The sand would get stuck in here and the water would drip through. The stuff that drips through, we call that the filtrate. Another means of filtration would be if you want to separate something much bigger. So you could think of a strainer or a colander that you would use for like spaghetti noodles. You want the noodles, you want to get rid of the liquid, so you put it in a strainer, much bigger holes. We use different layers, different levels of filtration, depending on what we're trying to capture. Some filter paper lets more through, and other filter paper lets less through. The more tightly it's woven, the less is let through, and the longer it takes for the filtrate to make its way through. Sometimes you might have to let it set overnight for it to get all the way through there. Another means of separation is magnetism. So I'm just going to doodle like a typical horseshoe magnet. And let's say we had a mixture of rocks and sand, but some iron shavings in here. What would happen is the magnet would only pick up the magnetized thing, so the iron shavings. Without a magnet, I can't imagine how you would separate this. Let's say you thought, I'm going to use tweezers. That would take you hours, and it's really just not. You just can't do that. Next up, this is going to get a little fancier. We have centrifuge. And I'm going to have a hard time drawing this. It spins really fast, and you put your vials in it. You're going to have some knobs to turn it on. And then in here, you're going to set your vials. Maybe it has liquid in it. And it's just going to spin it really, really, really fast. And it's going to use centrifugal force to force the solids to the bottom. In the medical field, they use this in lab with blood to separate the platelets. When you spin it really fast, all the platelets go to the bottom, so you'll find at the bottom of the test tubes a little bit of the white, and at the top are the red blood cells. So a centrifuge. If you'd like to Google that, pause the video, Google that image so you can see that. So if it's more dense, it's gonna get forced to the bottom. Now we have distillation. All right, and this is one, if you're going to pause and Google it, I would do a Google image search of chemistry lab distillation setup. Because these can get complicated. I'm going to talk about some of the lab equipment that we've already learned. So let's get drawing and try to keep it nice and neat. First thing we're going to use is a ring stand. And then we have to heat up something. So I'm going to use an iron ring. And on the iron ring, I'm going to set a beaker. And maybe in this beaker, I've got dirty water. Okay. And since we're going to heat it up, technically you could just use a hot plate. I'm going to draw a Bunsen burner. And we've got our fire all over the bottom of that beaker. That's to the gas line. Okay, so we've got our Bunsen burner heating up the water. Now, if we just use a normal beaker, we could separate by evaporation. So we could evaporate everything and the water would go into the air, and then you'd be left with, let's say it's salt water. The water's going to go in the air, and the bottom you'd have crystal salt. But sometimes we want to capture the water. We don't want just to go in the air. Maybe it's not water. Maybe, once again, it's isopropyl alcohol. So what we'll use, maybe instead of a beaker, we will use something that has a stopper, an Erlenmeyer flask, something we can seal off. So I'm going to draw this into a glassware that you can seal off with a stopper. And then we're going to put a distillation tube. We're going to connect it, and all that hot water vapor is going to be forced in here, is going to condense, and it will drip out over here. This would be our pure water. The more you distill something, the more pure it becomes to get everything out of it. Now, what we need to happen here is condensation. And if we just hooked it up the way you see it right now, this tube would fill with so much hot gas, hot water vapor, it would probably explode. So they've created this fancy thing. They take that tube and they surround it by more glass. And you would put a hose in cold water here. And it would swish around and it would come out this way, and you would have hot water because now it's hot from all the steam heating it up. And you just put a hose to a sink drain so that it could so that we could keep flushing cold water around this and make it condense faster. This piece of equipment right there is called a condenser. I've also heard it called like a condensation tube or a distillation tube, either. Now I want to show you a quick part of a video so that you can actually see how this works.
Of course, that water will need somewhere to go. So I'm going to place another hose on the upper hose bar, and that will run to the well sink in the back of the hood. Next, I'm going to turn on the water, being sure that I'm very careful about which one of the green knobs I'm turning, so I know which water spigot I'm activating. And it will fill the tube from the bottom to the top. Now the jacket of my West condenser is completely filled with cold flowing water.
All right, so you can see the water flowing through the condenser tube. Here is whatever he's distilling because he wants to capture whatever liquid this is and purify it down here. The stuff that is not pure that he wants out of there is going to remain in here in the bottom of the container.